Hello, this is Mrs. Huntley. This is Module 4, Systems of Equations. You should have your supplemental packet with the front cover that looks similar to this. And I would like you to turn in your packet to page 31, or about page 31. In the top left-hand corner, you should see this box that says Systems of Equations, student handout number 7. I'd like you to add the essential question at the top. How do I solve a system of equations using elimination? So this is the fourth and final method that I'm going to be teaching you to solve systems of equations using. And it's actually one that after surviving substitution, students tend to really love elimination. So let's go get to it. We've got some fill-in-the-blank notes. In cases where the variables in two equations have opposite coefficients, we can solve the system by elimination with the following steps. Line up the like terms in the equations. So you're going to line up the like terms. I'll explain what all of this is as we're going through the examples. Number 2, you're going to add the equations to eliminate one variable and solve for the other. So we're going to eliminate one variable and solve for the other. Step 3, we're going to substitute your answer into one of the original equations to solve for the other variable. And then, as always, we write our answer as an ordered pair. And as always, we should check our work. So what does this all mean? When we talk about opposite coefficients, we talk about the coefficients should be the same number, but an opposite sign. So if you look at number 1, I've got negative 2x plus 4y equals 4, and then I've got 3x minus 4y equals 2. So I've got a 4 as my coefficient here with the y, and I've got a negative 4 down here with the y. Those are opposites. The opposite of positive 4y is negative 4y. So I've already got an equation set up that is perfect for using elimination. So I'm going to add my two equations together. And I know this sounds a little bit weird, but I'm actually even going to put a big old plus sign out here. So I'm adding down. So I've got negative 2x plus 3x. So I'm adding down. Negative 2x plus 3x is 1x, or I could just write a plain old x. Positive 4y minus 4y is 0. As long as I've got something else on that side, I don't have to write the 0. And then I've got 4 plus 2 equals 6. So I'm saying my x is equal to 6. I've got half of it done. I know, you're going, oh my gosh, that's so much easier than substitution. And it is when both equations are in standard form and when you have a set of opposites already. When we don't have it set up perfectly like this, there are other ways to get it to be set up perfectly, and we're going to investigate all of that. But I didn't want you to think it was quite that easy. Okay, so I only have half of my answer. I've got to figure out the other half, so I've got to plug in or substitute in my x value for one of the x's in one of the equations and solve for y. Now, I tend to just pick the one on top because it's on top. I don't know. It doesn't have to be that one, but that seems to be where I go. I don't know why. You could use either one of them. So what I've done is I just took my 6 and I substituted it in for y, and now I'm just going to solve it. So negative 2 times 6 is negative 12, plus 4y equals 4. I need to add 12 to both sides of the equation. So 4y is going to equal 16. Divide both sides by 4, and y is going to equal 4. So I say the solution to the system is 6, 4. Now, of course, I can check. And the way I check is whichever equation I didn't use to solve for y, I'm going to use it to plug in both my x and my y and make sure it works. So 3x, or 3, not x, 3 times 6, minus 4 times 4, does that equal 2? 3 times 6 is 18. Negative 4 times 4 is negative 16. 18 minus 16 is 2, and 2 equals 2. So I know it's a good solution. Okay, number 2. is again set up perfectly to use elimination. Let's take a look at my set of opposites here. I've got 6x on the top and I've got minus 6x on the bottom. So my x's are going to be the things that get eliminated when I add these two equations together. So I'm just going to add down. 6x plus a negative 6x is going to be a 0, so I'm not even going to write that. I've got 2y plus negative 5y, which is going to be a negative 3y. And then 4 plus negative 28 is going to be a negative 24. Divide both sides by negative 3, and y is going to be equal to 8. So I've got half of my answer. Now I need to figure out the other half. Plug in my y equals 8 into either one of the equations. So 6 times 8 plus 2y equals 4. 6 times 8. Oh, you know what? I almost made a big mistake there. In fact, I did make a big mistake there. Hopefully you were not writing in pen, because I just plugged in my y value into my x and I didn't realize it. So it's going to be actually 6x plus 2 times 8, because I solved for y first, equals 4. So 6x plus 2 times 8 is 16, equals 4. Now I've got to subtract 16 from both sides, and 6x equals 4 plus negative 16 is going to be a negative 12. Divide both sides by 6, and x equals negative 2. So now I can check using my bottom equation, negative 6, instead of x I'm going to write negative 2, minus 5, instead of y I'm going to write 8, equals negative 28. Let's see if that works. Negative 6 times negative 2 is a positive 12. Negative 5 times 8 is a negative 40. Positive 12 minus 40 is negative 28. And negative 28 equals negative 28. So it's a good answer. Okay. What I'd like you to do right now is I'd like you to see if you can do the elimination piece in number 3. Number 3, again, is set up pretty perfectly. We've got a 4x minus 7y equals 47 in the top equation, and 6x plus 7y equals negative 17 in the bottom equation. So you should be able to just add them down, pause the video, get that part of it done, make sure that you've got that under control, and then unpause the video and continue solving. So when I add them down, I'm going to have 10x. Negative 7y plus 7y is 0. 47 plus negative 17 is going to be a 30. Now I can easily solve for x here. Divide both sides by 10, and x equals 3. Okay, again, I'd like you to pause the video, see if you can solve for y, and then unpause the video to see if you did it well. Okay, so when I solved it, I came up with y equals negative 5. Let's check our work, make sure that we didn't make any silly mistakes. Since I used that top equation to solve for y, I'm going to use the bottom equation to check. So 6 times 3 plus 7 times negative 5. Does that equal negative 17? Grab your calculator, or just do it in your head the way I tend to. That looks ugly. If I'd grabbed a calculator, I would have known that I shouldn't put that plus sign there. So 18 minus 35, does that equal negative 17? And yes, negative 17 equals negative 17. It's a good answer. Number 4, go ahead and pause the video. See if you can eliminate one of the terms and solve for the other term. Pause it. So the answer I came up with was 0, 9. You can use that other equation to go ahead and check my work. Does -5 times 0 plus 5 times 9 equal 45? Let's see, 5 times 0 is 0. 5 times 9 is 45. And 45 equals 45. Perfect. Okay, so what happens if our equations are not set up perfectly? Maybe they're going to be in standard form, but I don't have a set of opposites. What could I do? I'm so glad that you asked. Okay, so in situations where neither of the variables in the two equations have opposite coefficients, it may be necessary to multiply one of the equations by a constant in order to create opposite terms. So I might have to multiply the entire equation by something. Remember, when you have an equation, as long as whatever you're doing on one side of the equation is the same thing that what you're doing on the other side of the equation, you haven't changed its value. When we're multiplying an equation by a constant, remember to multiply each of the terms. So everything has to get multiplied by something. And I'm going to encourage you to keep it simple. So let's look at number 5 here. I've got -x plus 2y equals -13, and then I've got 2x plus 3y equals 12. To create a set of opposites, I need the same number coefficient but opposite signs. If you look at my x's, I've already got opposite signs on them. I just need to multiply this entire equation by 2. If I do that, I'm going to have a set of opposites. So I'm going to put parentheses around it, and everything is going to be multiplied by 2. So 2 times -x is going to be -2x, and I'm just going to line them up right below so I don't have to rewrite 2 equations. 2 times 2y is going to be a positive 4y, and then 2 times -13 is going to be a -26. My equal sign looks funny. So now I've got a set of opposites. Now I'm momentarily, and I'm not going to invite you to do this, but I'm momentarily just going to pretend that this equation doesn't exist anymore, because these are the 2 equations that I'm going to do the elimination on. Now I'm going to need that other equation, which is why I'm not inviting you to cross it out or to black it out or to do anything like that, because when I'm going back to check my work, I should use the original equation, just in case I made a mistake somewhere. So I'm going to add these 2 guys together. 2x plus a minus 2x, or plus a negative 2x, I'm sorry, is going to be a 0. But I've got 3y plus 4y, which is going to be 7y, equals 12 plus -26 is going to be a -14. Divide both sides by 7, and y is going to be equal to -2. So I've got half my answer there. Here's where I might go back to the original equation, just for the sake of easy math and for the sake of not making a math error. So I said y was -2. If I use my first equation to solve for x, I've got -x plus 2 times -2 equals -13. -x minus 4, because positive 2 times -2 is going to be a -4, equals -13. Add 4 to both sides. And -x equals -9. Now I don't want -x, so I'm going to divide by -1. And x equals +9. So I say my ordered pair answer is 9, -2. I'm going to use my bottom equation to check my work. So does 2 times 9 plus 3 times negative 2 equal 12. See, 2 times 9 is 18. 3 times negative 2 is minus 6. Does that equal 12? 18 minus 6 does equal 12, and 12 equals 12. So it's a good answer. Looking at the next equation, number 6. My top one, 4x minus y equals negative 19. And my bottom equation, negative 2x minus 5y equals negative 29. Now, we have choices here. I could multiply the top equation by negative 5, and then my y's would be opposite because I'd have a positive 5 at the top and a negative 5 at the bottom. But that gets into some really big numbers. And whenever I look at a system of equations, I try to keep my numbers as simple as I can. Okay? Looking at the bottom equation, I've got a negative 2 here and a positive 4 here. If I just multiply that entire bottom equation by 2, the math is a little bit easier for my brain to handle. Whoops, that's not what I meant to do. The math is a little bit easier for my brain to handle without a calculator. Sorry, I was distracted by something that oh my gosh, I just did it again. Why is that happening to me? Okay, let's try to undo that. Sorry about that. It didn't undo. There we go. So if I multiply that entire bottom equation by a positive 2, again, the math is a little bit easier for my brain to handle without a calculator. If you want to use a calculator, that's fine. I tend to not grab a calculator when I'm talking about easy math, but that's up to you. So 2 times negative 2 is going to be a negative 4x. 2 times negative 5 is going to be a negative 10y. And 2 times negative 29 is going to be a negative 58. Again, just for my own sanity, I'm going to temporarily cross that equation out so that I know I'm looking at the top equation and the bottom equation. If you need to rewrite something somewhere in order to be able to look at it without getting confused, by all means do that. So 4x plus a negative 4x is 0. Negative y minus 10y is going to be a negative 11y. Negative 19 plus a negative 58 is going to be a negative 77. When I divide both sides by negative 11, I get y equals 7. So I'm halfway there. Going to use that top equation. 4x, let's change colors. 4x minus 7 equals negative 19. Add 7 to both sides. 4x equals negative 12. Divide by 4, divide by 4, and x equals negative 3. Now I don't want to black out that bottom equation because now I'm going to use it again. I need to use it to check my work. And I'm going back to the original again because the numbers are smaller, first of all. And secondly, if I had made a silly mistake multiplying, I don't want that silly mistake to carry through. So if I had used my transformed equation, that silly mistake might have been something that came back to haunt me. So let's take a look at my answer, substituting it into that equation. Negative 2x, I'm sorry, negative 2, instead of x, I'm going to say negative 3. Minus 5, instead of y, I'm going to say 7. Does that equal negative 29? See, negative 2 times negative 3 is a positive 6. Negative 5 times 7 is a negative 35. Does that equal negative 29? 6 minus 35 is negative 29, and negative 29 equals negative 29. So it's a good answer. What I'd like you to do now is see if you can figure out what to do on this one. I've got negative 3x plus y equals negative 8. Then I've got 4x plus 3y equals 28. Now, I do have choices on what I can multiply by, but remember, I want to keep it simple. In my opinion, the easiest one to transform would be to get these y's to match up. So I would need to multiply the top equation by a negative 3 to get a negative 3y up here, so that when I'm adding them down, the y's are going to be eliminated. Over here, I'm not going to do this because we're running real tight on time. Over here, again, I want you to look at these and see if you can figure out what you would multiply either the top equation by or the bottom equation by to get a set of opposites. It could be an opposite x or an opposite y. What I am going to do before we take off, because this is kind of a way of wrapping up the explanation, it says, explain below when you think the method of elimination would be most helpful to solve a system of equations rather than one of the previous methods we learned. And I'm going to give you the answer here. When both equations are in standard form. We've talked about standard form. Standard form is that ax plus by equals c format, where a, b, and well, where at least a, b, or c are not 0. You could also say when neither Neighther equation is in slope-intercept form. Because if one of them is in slope-intercept form, it might be easier to just use substitution. And when both of them are in slope-intercept form, it's probably easier to just graph them. Okay, so that is going to conclude today's lesson. You could actually summarize it, because the essential question was, how do I use elimination? And I did not answer that. I just answered when you use elimination. So go ahead and summarize the lesson. Think about these last two problems and come to school with any questions that you have. Have a good night.